That's one point. And then the other point is that, there is a very interesting phenomena that essentially comes from the requirement that the trace wave number in y direction in the medium as well as on the plate has to be same. So KB has to be same as K, if you like, K0 sine theta 0. But we found that the pressure, because the pressure is normal to the surface, therefore there must be cosine term, right? And due to that requirement, we have interesting phenomena, supersonic, subsonic phenomena. Okay? And lastly, note that the pressure due to incident and reflected and transmitted on x equals 0 has to be equal to my double dot plus b y to the fourth. Okay, that's the bending equation. The assumption, what is the assumption related with this expression? Here is a plate. The plate has to be thin plate. What does it mean by thin plate? Thin means the plate has to be less than 1 millimeter. The thin plate means that the plate has to be less than 1 meter. What does it mean by thin plate? Huh? Small compared with the wavelength. That's a good point. But when we derive this, we do not consider the wavelength at all. But so thin plate assumption has to do with something that is not related with the wavelength. So what was it? Okay, I'm sure you guys remember very clearly, but you do not want to speak out not to make your classmate or friend to be disappointed. So I would say thin plate means that the cross section of beam or plate okay, here is a cross section. When it bends, the cross section of a plate is simply rotate. Cross section remains plane. Okay, that means a shear effect, because a shear will make your cross section not just remain plane, but if there's a shear, it will be deformed, right? So simple beam, thin means the thin enough to follow that assumption. That means only bending rigidity is dominating, not shear force across the section. Suppose the beam is very thin. The shear distribution in cross section, it would be very small compared with the bending. Right? Right? So in that sense, what he mentioned, wavelengths would have some meaning. If wavelength is very long compared with the cross section, then it should follow this assumption related with the thin plate. So in other words, thin plate means that simple beam or plate. Okay? Right. So we neglect shear. Shear effect is negligible. Negligible. Now let's use that, as he mentioned, the wavelength is very, very long compared with the thickness of plate as our rather acceptable physical situation. So what he mentioned was right. Okay. Now, it is interesting to note that the bending wave, the characteristics of a bending wave is rather interesting. That can be observed immediately from this differential equation. It has rate of change with respect to time twice, or that has a rate of change with respect to space 4 times. Dong-Soo, you have a question? Okay. So to know the characteristics of bending wave, well, let's examine how it behaves when there is no external force. Okay? For instance, when we have simple vibration, there is an external force. The equation of motion, if I denote this is eta, would be my double dot plus r y dot plus sy, that is ft. If you want to know the characteristics of this system, what we do, we set ft equals 0 and solve it. That we are solving eigenvalue problem. Right? So by the same token, we set this one as 0 and solve that equation. So let's look at this case. Then, sorry, this is not y, eta. I'm sorry about that. And then let's use this assumed solution, plug this governing equation. Then we have m omega square, right? And then I will take the derivative with respect to y 4 times. I have plus jkb. Take one derivative with respect to y. I have jkb. One more minus jkb square. One more minus jkb to the third. And one more I have plus kb to the fourth, right? That is 0.